All right, Chapter 12 is all about sampling. So I've underlined some important vocabulary words today. Be sure to look at these in your textbook as well. So when we sample, we want information about a population. Population, you're thinking of a big group. It could be a big group of people. Could be all of the students at Granger High School. That's a population. Could be all of the dolphins on the planet Earth. Okay, big whole group. But instead of taking measurements from the entire population, by the way, that's called a census. We don't do that. Instead, we examine a small group. It's called a sample. And we want our sample to be representative or reflect what the population really looks like. How we collect the sample could result in bias. And we'll talk about bias specifically in the next video. So remember, the goal is we have a population, a big group. We can't ask everyone or measure everything in that group. So instead, we take a small piece, we call it a sample, and we're hoping our sample will be representative. It will look like or reflect the real population. So a couple important things that you need to know. When I'm talking about populations, we're going to refer to parameters. That's a characteristic of the entire population. If I'm talking about dolphins on the planet Earth, maybe I want to know how much they weigh. So when I talk about a characteristic, maybe I'm talking about average weight. Okay, that could be a characteristic of the entire population. Because we don't ask the entire population, we only look at a sample, then we get what's called a statistic. It's an estimate, a guess of the parameter based on a sample. I'm not going to go out and weigh every dolphin on the planet Earth to find out the average weight of a dolphin. Instead, I might sample a few dolphins and get my guess for the average weight of a dolphin. All right, so that's the difference. I remember that population goes with parameter because they both start with P. And I remember that sample goes with statistic because they both start with S. So here are some examples of how we talk about these in statistics. If I'm talking about means, right, or averages, the parameter, the true average, if I could magically go out and measure every dolphin on the planet Earth, the real average would be mu. But I can't go out and measure every dolphin on the planet Earth. That's preposterous. So instead, I sample, I don't know, maybe I can find 50, and I take the average. That gives me X bar. We're starting to see why we have those two different symbols that both mean average. The same is true for standard deviation. If I go out and I was magically able to get every dolphin on the planet Earth, I'd use sigma. Since I can't, I just have a sample. We use S for standard deviation. Proportions we'll see come in Unit 5 a lot more. But proportion, think percent. If I wanted to know, perhaps my population is Granger High School, I want to know what percent of Granger High School likes ice cream. If I could go and ask every single student, okay, I'm talking the ones who are sloughing, the ones who are homesick, everybody, that would be P. That would give me my proportion or my percent. But I probably won't be able to catch everybody, so I'll have a sample, and we call that percent P hat. P hat. So keep in mind, parameter is the truth. This is what's really happening, but it's hard to find. It might be impossible to find because we can't gather every piece of data from a population. So instead, we get our statistic, which is a guess. And hopefully, if we have a good sample, our guess will be close to the truth. There are several ways we can take samples, and I'm going to mention the 4 that are in your textbook. And my personal favorite is the simple random sample. You will often see that referred to as SRS. This is where every possible set of people has the same chance of being chosen. And I like to call this the names in a hat. It's the simplest and guaranteed to give you what you need. So if you were asked to come up with a simple random sample, names in a hat is the way to do it. A stratified sample is where we're grouped based on similarities. And then I'm going to do an SRS for each group. By the way, grouped on similarities we call homogeneous. You might see that word. Cluster sample, kind of opposite. These are going to be heterogeneous groups where we don't have a lot in common, right? It's a good mix. And then we choose all of a cluster. And I'll go through and give a couple examples. The last is systematic, right? We follow a system. Could be like every 5th person down a list. All right, so let's think about our high school. If our population was all the students at Granger High School, let's talk about how we would do each one of these samples. A simple random sample, I would get all the names of every student. I would put them in a hat. And then without looking, right, I'd mix up all the slips of paper and I'd pull some out. I don't know, if I want a sample of 50, then I'd pull out 50 slips of paper. I'm not going to put them back. That way I'm getting new students every time. A stratified sample. I know that there are some similarities at our school. So perhaps I want to stratify on your grade level. So now instead of putting all of the names in one big hat, I put them in, what's a hat? 3 big hats. Right? Here are my 10th graders, my 11th graders, my 12th graders. And then I do a simple random sample from each hat. So maybe out of the 10th grade hat, I pull, I don't know, 15 names. And out of the 11th grade hat, I pull 15 names. And out of the 12th grade hat, I pull 15 names. That way I know I have some of everything. Cluster sample is going to work very differently because these I want heterogeneous groups. So a lot of high schools have what's called a homeroom, and you're just assigned to a homeroom. You may not have anything in common with the rest of those students. So everybody that's in a homeroom, each homeroom has like a hat. Okay, and I don't know, this is Miss Curtis, this is Mr. Clausen, this is Miss Peterson, and so on and so forth. So here, I'm going to choose everybody in a cluster, or maybe 2 or 3 clusters. So I might randomly choose, well, hey, guess what? We're going to ask all the students in Mr. Clausen's homeroom. We're going to ask all the students in Miss Peterson's homeroom. We're going to ask all the students in, I don't know, Mr. Moon's homeroom. So I don't pull out some from the hat. I use everyone in that group. The last is a systematic sample. So I might go and get an alphabetical list of every student at our school. And then I would choose a random starting location, maybe using a random number generator. Okay, so randomly I've chosen that I'm going to start at person number 3. And then I'm going to pick every 5th line. Okay, so this person gets asked, then I go down 1, 2, 3, 4, 5, and this person gets asked. I go 1 down 5 more, and that person gets asked. All of these sampling methods are appropriate and will give you good representative samples.